Hello, everyone. This is Martha. Once again, we're going to be talking about some pre-calculus, and believe it or not, I'm actually really excited to talk about this section. It's the properties of logs, and knowing these patterns and these behaviors, I guess the way I think about it, can make a big difference, and it's kind of fun to switch back and forth between them. So I'm just going to write out the properties, and then we're going to practice and play a little bit with it. So, and this is taken from the book. M and N are numbers, variables, whatever. They have to be greater than 0, both of them. And for condensing and expanding logs, we want to pay attention to what's in the parentheses attached to the log, what's going on in there, or if we have a plus or a minus and logs with the same base. The first one is going to be the product rule. So if you have a log with some base, we're just going to say b, and inside of the parentheses, you have m times n, or two things being multiplied together. That is equivalent to log, keep that same base that it has, m plus log, same base with n. Now this also works if we're told to condense something and we have log base b m plus log base b n. We can condense it back. We can bring these two things together within a parentheses. So log base b and m and n are multiplied together. So when we see the plus, think multiplication. So that's the product rule. Next, we're going to do the quotient rule, and quotient is all about division. So if we have log base b and we have m divided by n, we can expand that out, log base b m minus, big minus, log base b of n. And if we're condensing things down, the same thing holds where if we've got log base b m minus log same base b n, we can condense it down into log base b m over n. And the last one that we're going to talk about is the power rule. Now with the power rule, it deals with exponents or things raised to a power. So if we've got some log with some base, and we have some m, something raised to a power, we get to bring it down front. And it's p, whatever that power is, times log base b of m. Now let's see if we can find some examples of how these things work. We're going to start off with some easier ones, and we're going to go from there. So let's say we've got log base b parentheses x squared, x squared times square root y. Okay, we've got the parentheses and we've got things multiplied together. So we can say that this is equivalent to log, we keep that same base b, x squared, and remember multiplication goes with addition, log base b y square root of y. Now there's one more thing that we can do with this product rule, or with the, not the product rule, the power rule. Let's rewrite this as that log base b And we're going to use the power rule and bring the 2 down. So it's x squared, we bring that 2 down, and that becomes 2 log base b x. And this square root of y, we can write that as log base b, but y to the 1/2. Because anytime we have a root, that number, we can make a rational exponent by having that number in the denominator. And we can bring that 1/2 down, so plus 1/2 log base b of y. And we have expanded this out. Now let's try one that's a little bit more complicated. This one is going to be log base 6, and it is x cubed over 36 y to the 4th. And we're going to split it up. The blue is going to be the top, and the green is going to be the bottom. And remember that when we're rewriting it, it's the top minus the bottom. So we've got log base 6, and then we write whatever was in the numerator or in the top, and that is the cubed root of x minus log of 36 y to the 4th. All right, so far so good. And let's see what we can do with each piece. This first thing right here, we can say, okay, this is log 6 x to the 1/3. We're going to bring that 1/3 down, and it's 1/3 log 6. We're going to do minus. And we have to be careful here because we've got two things being multiplied together. This 36 and this y to the 4th. And so we're going to add those two things together. I'm going to put some parentheses around this. So I'm going to do log base 6 of 36 plus log base 6 of y to the 4th. I'm going to distribute this negative through, so it becomes 1/3 log 6x, oops, there we go, minus log base 6 of 36 plus log base 6 of y to the 4th. Now I see one thing I can do, I can use the power rule to bring that 4 down. So rewriting everything, we've got 1/3 log base 6x minus log base 6 36 minus, that should have been a minus. There we go. 4 log base 6 of y. Now it might look like we're done, and we are almost done, but this 36 right here, we can do something with that. We're going to change the way that it looks and help us simplify this even more. Now this 1/3 log base 6 of x stays the same, and we're going to write 36 as 6 squared. Log base 6, 6 squared, minus 4 log base 6y. And right here we've got the principle where any log with the same base, it's just the exponent that's left. So rewriting our final answer, we've got 1/3 log base 6 of x minus 2 minus 4 log base 6 of y. And that is our final answer for expanding this up here. And it may not seem like, it may seem just like busy work, but when you go on to further maths, this helps a lot. And also, it's just sometimes helpful to think in terms of learning how to be more flexible in our thinking. And I think we've got time for one more expansion, or so this was expanding, and we're going to try and do some condensing really quickly. There we go. All right, so let's take, we have 3 ln, and that's just the natural log, x plus 7 minus ln x. And this, instead of expanding, we're going to be condensing. So let's see what we can do. We've got this minus up here. So I know that, and the same base of ln, this x plus 7 to the third, because of the power rule, is going to be my top, or my numerator, and this x is going to be my denominator. So let's rewrite this. We've got ln of, nice big brackets here, x plus 7, all that cubed, over x. And that is our final answer. Whee! I wish we had time to go over condensing for a longer example. If you want to see one, leave a comment and we'll make a video. Have a great day and have fun practicing this.